Hi everyone, I'm Tom Yanarelli, your EAC instructor. What normally is a 6-week course is now online, so I'm going to be teaching you everything that you would learn in that 6-week course. First of all, let's take a look at the Student Pledge. Looking at the Student Conduct Pledge, if you read along, all B-Works participants must sign below to accept the Student Conduct Pledge. Number 1, I will be on time and prepared for each weekly online class. Number 2, I will complete the assignments for each of the required 6 classes and return my work on time. Number 3, I will be an active participant in my learning. I will pledge to be a good participant during the B-Works online class. I am willing to learn and participate in the course so that I will be safe with and take care of the items I use during this course. I understand that not following these above rules will end with returning the computer. Right there, you should sign. Now, parents. A parent guardian of B-Works participant must electronically sign below to acknowledge the attendance guidelines, and this paperwork must be turned in prior to being issued a computer. I understand that if my child is to miss a day of class, I will let a staff member know in advance or risk my child's participation in B-Works programs. I understand that if my child misses one day of class without notification, my child may be removed from the course. I understand that if my child is dismissed from the program, he or she or they will be placed at the end of the waitlist. I understand that if my child fails to meet the requirements to graduate the class, that B-Works will ask for the return of the computer. Failure to return B-Works property will result in the family not being eligible for B-Works programs in the future. The first part of our class is going to be hardware. We'll be learning how computers store data, some of the hardware, and how Scratch is used, and we'll introduce Scratch a little later. Computer hardware. There are a bunch of things in a computer. The first thing that we're going to talk about is the motherboard, right here. The motherboard connects all internal and external parts of the computer together. All of these little slots right here, that's where a lot of things get plugged in, like video cards and printing cards, etc., etc. All of those things are able to communicate with each other when they're plugged into the motherboard. The CPU, or central processing unit, is the brain of the computer. It runs all of your programs. It only understands ones and zeros, which we'll get to in a minute. They generally have multiple cores, as you see here, and they need a big fan to keep them cool. RAM, or random access memory, is working storage. It makes a computer much faster, especially when it's under a lot of work. They can be expensive though, so if you're trying to upgrade your computer, you might want to think about that twice. Hard drives store large amounts of information. The storage lasts a long time, so most people store computers, files, etc., on those. There's 2 types of them, an HDD and an SSD, which is solid state, like a USB drive, but much faster. When we're comparing the two, RAM memory is very fast, it's only working storage, so it's temporary, expensive, and doesn't get very high in storage. Hard drives tend to be slower, but they last a lot longer, and it costs less per gigabyte. They get very large. Some of them are even terabytes large. When a computer loads a program, the CPU starts it off loaded. It's basically stored on your hard drive. This hard drive sends it to the RAM, which runs it in between the CPU and the RAM, and when you're done, the CPU saves your program. Other important hardware: power sources. They're responsible for supplying the computer with power, and optics drives. They use lasers to read CDs, DVDs, etc. They're better known as DVD players. Binary code is a series of ones and zeros. 1 means on, 0 means off. basically a numbering system. We learn to count on the decimal system. We go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, there's a 0 again. What do we do? Well, we've been taught to add a place value. So we add a tens place so that when we count up to 99, we can end up adding another place value for the hundreds spot. Binary code does it a little differently. It uses the exponent of 2 and adds all of those numbers together. So at the zeros place, if there's a 1, basically a computer will say, do I add that or do I not add that? Anything to the power of 0 is always 1. So if there's a 1 in the 0 spot, it'll add 1 to the addition problem. If there's a 1 in the ones spot, anything to the power of 1 is always itself. So it would be 2. So it would be 2 in the addition problem. See right there? And so on and so forth. Storage is basically in bits. Memory starts at 1 bit, is very, very small. Kind of like a switch, on and off. 8 bits is a byte, kind of like byte works. And it ends up getting bigger and bigger and bigger very quickly. When you're typing letters on your computer, basically it's like language. Binary with that addition problem added with a bunch of different numbers put together ends up making a word, kind of like C plus A plus T make cat. Binary works similarly as codes for letters, symbols, etc. For the next few videos after this one, we'll be using a program called Scratch. If you've never used Scratch before, I'll give you the rundown. Over here, if you're following my mouse, you'll see the stage and ScratchCat. Most of the characters that you've created, they're called sprites, will be found in here. There are 3 ways to create sprites. You've got draw a new sprite, choose new sprites from file, or get a surprise sprite. When you're playing your game, there are 2 controls that you're going to want to know. Stop it, everything, and start your program. Over here, this is the script editor. You'll see ScratchCat's position right here. It's 0, 0 on a regular graphing plane. The name of ScratchCat is right here. You see is at sprite 1. Over here, you have commands, many, many commands. This is your command menu. You have 8 different types of commands. You have control, sensing, etc., etc. We'll be showing you how to use these specifically to make your games. Once you've finished your game, you're going to save it as. Once you've saved it, you've got your file name down here. You'll be able to record your file, and it'll save into Scratch projects. Or if you're like me, you'd want to use your desktop. Your first challenge in Scratch is going to be trying to get ScratchCat onto a specific coordinate. Now you're going to want to write these down. Find a way to get ScratchCat to where x equals 20, y equals 100. On your mark, get set, go. Yeah, you're going to beat me. Let's see if I can get it at the right spot. 20, 100. Let's see if I can do it. It's hard to do with a touchpad. Got it. Now that's not the only way you can do it. You can also go to Control, when green flag clicked, Motion, go to XY, and if I move ScratchCat, you notice that he's at minus 200 and minus 19. If I just type in 200 and 100 and click either there or click the green flag, there he goes. So there's multiple ways to do it. Preferably, we want you to program him to do that.